Attention, master decoders! You cracked the case of algebraic expressions, but are you ready for the ultimate upgrade? Welcome to the world of simple equations. If expressions are secret codes, equations are the actual locks we need to open. Today, we're not just writing the code, we're finding the one specific key, the number, that makes everything perfectly balanced. It's like a high-stakes puzzle where only one piece fits. Grab your detective gear, because Focus 1, Knowing Equations, starts now. Let's start with a warm-up on slide 2. Look at these boxes. Something plus 2 is 5. We all know it's 3, right? And something minus 4 is 6. That's 10. But in the world of professional detective work, we don't just use empty boxes. Boxes are for kittens. Spies use letters. The logic is the same. Find the number that makes the left side equal to the right side. It's all about balance. If the scale isn't level, the case isn't closed. Remember our stationery shopkeeper? He's back. He's raising prices by $5 again. Original price is X, new price is X plus 5. That's just an expression. But look at slide 4. If we know the new price is $15, we can write X plus 5 equals 15. That equals sign is the most powerful symbol in your kit. It turns our expression into an equation. Now the mission changes from writing a rule to finding the X. What number plus 5 is 15? 10. Our mystery price is solved. X is 10. Boom. Case closed. Now, the discount sweater on slide 5. Price C minus 50 is the expression. On slide 6, we find out the new price is $140. Our equation, C minus 50 equals 140. Think about it. What number gives you 140 if you take 50 away from it? You have to give that 50 back to find the original. 140 plus 50 is 190, so C is 190. You see the pattern? Equations tell us the end of the story, and we work backward like detectives to find the beginning. Hungry for more? Slide 8. $7 per topping. Ye toppings. Total cost $28. Equation? 7y equals 28. What times 7 is 28? 4. 4 toppings for Tony. And slide 10, teddy bear cloth. M pieces divided by 4 portions equals 6 pieces per portion. Equation? M over 4 equals 6. If we split M 4 ways and get 6, the original must be 4 times 6, which is 24. Notice how multiplication and division are just mirror images of each other? It's like looking in a math mirror. Let's get official on slide 11. An equation is a mathematical statement showing two things are equal, and it must have an unknown. If there's no unknown, it's just a boring fact. If there's no equal sign, it's just an expression. An equation is like a locked door with a specific key. X plus 5 is 15. C minus 50 is 140. These are all equations. They are the language of balance. If the left side doesn't match the right side, the universe starts to wobble. Just kidding, but your math teacher might. How do we find the key? Look at slide 12. Equation. A plus 6 equals 10. Let's try A equals 2. 2 plus 6 is 8, not 10. Different. Try A equals 3 on slide 13. 3 plus 6 is 9. Almost. Finally, on slide 14, we try A equals 4. 4 plus 6 is 10. It matches. Slide 15 gives us the formal name. The number that makes both sides equal is called the solution. Think of it as the unlock code. When you find the solution, the puzzle is solved and the detective gets a gold star. Time for a quick roundup. On slide 16, which are equations? T minus 5 equals 12? Yes, equals sign plus unknown. 8 times 7 equals 56? No, that's just a true fact, but it's missing the mystery unknown. On slide 17, finding solutions? For U minus 8 equals 19, the key is 27. For F over 7 equals 14, the key is 98. You're spotting the keys and unlocking the doors like a pro agent. Focus 1 is officially in the bag. Mission 1, success. You now know exactly what an equation is and how to find its solution using your brain and a little bit of trial and error. But real detectives don't just guess numbers, they have a system. In part 2, we're going to learn the balanced scale method to solve equations even faster. It's going to be epic. Go grab a glass of water, calculate the volume later, and I'll see you in the next case. Keep those brains sharp, detectives. Welcome back to the lab, agents. You know what an equation is, but now I'm going to show you the ultimate secret weapon for solving them, the balance scale. Think of an equation like a perfectly level scale. If you add a heavy rock to one side, it tips over, unless you add the same rock to the other side. Today, we're going to use this do the same to both sides rule to uncover our mystery letters. It's fair, it's balanced, and it's the only way to keep the math universe from collapsing. Let's check out slide 18. Slide 18 is our mission briefing. If we have to add or take away something from our equation, we must do it to both sides. If I give the left side a cookie, I have to give the right side a cookie. If I take away a heavy boot from the right, I take it from the left too. This is the golden rule of balance. Without it, our detective work is just guesswork. Let's see it in action with a real mystery on slide 20. On slide 20, we have y plus 4 equals 9. The plus 4 is blocking our mystery IY. To get rid of it, we do the opposite. We subtract 4 from both sides. 4 minus 4 is 0, y is finally free, and 9 minus 4 is 5, so y must be 5. Check out slide 22 for 5 plus h equals 12. We subtract 5 from both sides to find h is 7. Slide 24 shows 16 equals p plus 7. Subtract 7 from both sides. P is 9. The way of thinking is simple. Addition's enemy is subtraction. Use it to isolate your mystery person. But what if our mystery letter is being robbed? On slide 28, we have x minus 3 equals 5. Someone took 3 away from x. To rescue it, we give those 3 back to both sides. X minus 3 plus 3 is just x, and 5 plus 3 is 8. X is 8. Slide 30. R minus 7 equals 9. Add 7 to both sides. R is 16. Slide 32. 14 equals E minus 6. Add 6 to both sides. E is 20. The way of thinking here, if you see a minus, you use a plus. It's like a math rescue mission. Give back what was taken, and the mystery is solved. Now for the squish. On slide 36, we have 3b equals 6. That means 3 times b. They are squished together. To separate them, we use the opposite of multiplication, division. We divide both sides by 3. 3b divided by 3 is just b. 6 divided by 3 is 2. So b is 2. Slide 38, 5k equals 30. Divide both sides by 5, k is 6. Slide 40, 6l equals 24. Divide both sides by 6, L is 4. Multiplication is a strong glue, but division is the super solvent that dissolves it. Always keep the balance by dividing both sides by the same leader number. Wait, detectives! Before you go, slide 23 has a vital tip. Always check your answer. Once you find your solution key, put it back into the lock to see if it actually turns. If you think H is 7, check. Is 5 plus 7 really 12? Yes. Then your solution is correct. If the scale doesn't balance, your key is a fake. You've just learned how to defeat addition, subtraction, and multiplication locks. You're becoming the most feared math agents in the city. In part 3, we'll tackle division locks and some real head scratchers. See you in the next briefing. Stay balanced. Agents, we have a situation. You've mastered addition, subtraction, and multiplication locks, but the villains have upgraded their security. They are now using division locks. They've split our mystery numbers into tiny pieces, and we need to put them back together. In part 3, the division dilemma, we're going to learn the final move in our balance scale technique, the multiplication rescue. But first, a quick brain teaser to make sure your detective minds are sharp. Let's look at slide 43. Slide 43 is a classic spy code. Green square is 3, red circle is 5, purple rectangle is 8, and square rectangle is 19. Wait, 3 plus 8 plus 8 is 19. So the code is addition. Now what is circle, circle, square, rectangle? That's 5 plus 5 plus 3 plus 8. 5 and 5 is 10, plus 3 is 13, plus 8 is 21. The answer is D. And for the triangle mystery below, if triangle times 5 is greater than 30, the triangle must be greater than 6. Because 6 times 5 is exactly 30. So the answer is C. Logic circuits activated? Good. Let's save some fractions. Here it is on slide 44. G divided by 3 equals 4. Our poor mystery G has been sliced into 3 pieces. To make G whole again, we need to do the opposite of dividing by 3. What's the opposite? Multiplying by 3. But remember the golden rule. What we do to the left, we must do to the right. So, we multiply both sides by 3. The 3's on the left cancel out, poof! And on the right, 4 times 3 becomes 12. G is 12. We put it back together. Slide 45 confirms it. Multiplying both sides keeps the scale perfectly balanced. You're a math surgeon. Let's run some more rescue missions. Slide 46. D divided by 4 equals 5. We multiply both sides by 4. D is freed, and 5 times 4 is 20. D equals 20. Checking, 20 divided by 4 is 5. It works! Slide 48. 3 equals F divided by 5. Don't let the order fool you. We still multiply both sides by 5. 3 times 5 is 15, so F is 15. And slide 49, Q divided by 6 equals 7. Multiply by 6, Q is 42. See the pattern? If it's divided, you multiply. It's the anti-slice maneuver. Time to prove your skills in the consolidation zone. Slide 50, C over 9 equals 8. Multiply both sides by 9. 8 times 9 is 72, so C is 72. Slide 51, 10 equals H over 12. Multiply both sides by 12. 10 times 12 is 1 to 20, so H is 120. You are flying through these. You now have the power to solve any simple equation. Plus, minus, times, or divide. You have the complete set of keys. Mission accomplished. You have officially conquered Focus 2, solving equations. You can balance any scale and find any mystery number. But detectives, the world is full of messy problems that don't look like neat little equations yet. In Part 4, we're entering Focus 3, Solving Problems. We're going to take real-world stories and turn them into equations ourselves. It's the ultimate test of a math detective. Rest up, sharpen your pencils, and I'll see you for the next big investigation. Detective Agency, over and out. Welcome back, elite agents. You've learned the rules of the scale, but now the world is throwing stories at us. On slides 52 to 65, we're entering Focus 3, Solving Problems. This is where we take a messy situation, like a box of rotten pears or a toy car sale, and translate it into our beautiful secret language of algebra. It's like being a translator for numbers. Once you can turn a story into an equation, you can solve any problem in the universe. Are you ready to become a math storyteller? Let's kick off with slide 52. Slide. Look at slide 52. This is our briefing. We have statements like 3 times C is 6. We have to pick the right code. Is it C plus 3? No, that's addition. Is it 3C equals 6? Yes, because times means multiplication squishing. And for subtracting 4 from W gives 8, that's W minus 4 equals 8. See? Every word has a math symbol hiding inside it. Is and gives are just fancy ways of saying equals. Once you spot the secret symbols, the equation writes itself. Let's look at Shirley's candy dilemma on slide 53. She has 42 candies total. 18 are milk candies, the rest are jelly. Slide 54 reveals our secret recipe for solving. 1. Let X be the mystery jelly candies. 2. Write the equation X plus 18 equals 42. 3. Solve it by subtracting 18 from both sides. X is 24. 4. Answer in words. There are 24 jelly candies. And the most important step on slide 55. Check. Does 24 plus 18 really equal 42? Yes. The scale is balanced and the candies are saved. This 5-step recipe is your best friend for every word problem. Mission. The toy car sale. Slide 57. Selling price is $68 after a $20 discount. What was the original price? Let's use our recipe. Let you be the original price. The story is original minus 20 equals 68. Slide 58. We solve it by giving back those $20. Y minus 20 plus 20 equals 68 plus 20. Y is 88. Slide 59 reminds us to check. 88 minus 20 is 68. The detective gets the car and the correct answer. It's like shopping, but without actually spending your pocket money. High-flying math on slide 60. The toy plane is $5 higher than the car. We know the car is 68. If the plane is H, then H minus 5 equals 68 because the car is the lower number. Slide 62. Add 5 to both sides. H is 73. The plane costs $73. The way of thinking here is comparison. Always ask yourself, which one is bigger? This tells you where to put the plus or minus. If the plane is higher, we subtract the difference to get back down to the car. Clear for takeoff, agents. Time for some consolidation. Slide 64, 34 balls total, 16 are footballs. Let B be basketballs. B plus 16 equals 34. Subtract 16, B is 18. 18 basketballs in the storeroom. Now, slide 65, the rotten pair case. 7 pairs are rotten, 89 are good. Let P be the original number. The story is original takeaway 7 rotten equals 89 good. P minus 7 equals 89. Add those 7 back. P is 96. 96 pairs originally. I hope we threw the rotten ones away. You are translating these stories like a professional spy. Focus 3 is becoming your playground. Part 4. Mission complete. You've learned how to turn addition and subtraction stories into solid equations and solve them using our secret recipe. You're not just math students, you're world-class translators. But don't get too comfortable. In Part 5, we're going to tackle multiplication and division stories. We're talking cereal boxes, jogging tracks, and tea parties. It's going to be a math feast. Take a break, check your own candy bags, using algebra, and I'll see you for the next briefing. Keep decoding, superstars. Welcome back, Master Decoders. You've translated the addition and subtraction stories perfectly. But today, the cases are getting heavier. We're talking about massive amounts of cereal, long jogging tracks, and enough tea to fill a swimming pool. On slides 66 to 74, we're tackling multiplication and division stories. This is the heavy lifting phase of your training. We need to be careful. One wrong move and the cereal boxes might topple over. Are you ready to solve these big-scale mysteries? Let's dive into slide 66. Mission: the cereal stockpile. Slide 66. Samson has 5 boxes of cereal, and together they weigh 750 grams. What's the weight of one box? Let's use our secret recipe. Let D be the weight of one box. The story is 5 times D equals 750. Slide 67 shows the solve. We use our division solvent to unsquish the 5. 5D divided by 5 equals 750 divided by 5. D is 150. One box is 150 grams. Checking, 150 times 5 is 750. The scale is level, and Samson has enough breakfast for a month. Logic: multiplication stories are solved with division. Slide 68. Grandpa is on a fitness mission. One round is a quarter kilometer. He jogged 2 kilometers total. How many rounds? Let F be the mystery rounds. The story is F divided by 4 equals 2. Why? Because every 4 rounds makes 1 whole clom. Slide 69. We rescue AF by multiplying both sides by 4. F is 8. Grandpa did 8 rounds. That's a lot of running. The way of thinking here: if the story slices the mystery rounds into quarters, we use multiplication to build the whole picture back up. Go, Grandpa! Time for tea. Slide 70. Mum fills 6 teacups, each holding 55 ml. How much was in the bottle? Let T be the mystery tea bottle. Story: T divided by 55 equals 6. Slide 71. Multiply both sides by 55. T is 330. The bottle held 330 ml. But wait, slide 72 has a plot twist. Can we write it differently? Yes. T divided by 6 equals 55 dots also works. Both equations tell the same story. 6 groups of 55 ml equals 1 whole bottle. Algebra is flexible like that. There's more than one way to write a success story. Consolidation time. Slide 73. 6 bookshelves. 540 books total. Let L be books per shelf. 6L equals 540. Divide by 6. L is 90. 90 books on every shelf. That's a heavy library. Now slide 74. The pastry chef. He slices butter into 5 parts, each 45 grams. Let W be the whole butter weight. W divided by 5 equals 45. Multiply by 5. W is 225 grams. The way of thinking remains consistent. Identify if you're squishing things together, multiplication, or slicing them apart, division. Then use the opposite move to find the mystery. Mission: the gift shop ribbon. Slide 75. 12 sections cut, each 30 centimeter long and 80 centimeter left over. What was the original length? This is a double-decker mystery. Let D be the original length. The story is original minus 12 times 30 equals 80. We have to multiply first. 12 times 30 is 360, so minus 360 equals 80. Now use our rescue code. Add 360 to both sides. D is 440. The ribbon was 440 centimeter long. You just solved a multi-step mission like a pro. Logic: handle the known multiplication first, then rescue the letter. Slide 76, the two-part scale challenge. First, a banana plus 100 grain equals 200 grain. X plus 100 is 200. Subtract 100, X is 100. So 1 banana is 100 grams. Now for the cake, 5 bananas equals half a cake. If 5 bananas weigh 500 grain, 5 times 100, then y over 2 equals 500. Multiply by 2, y is 1,000. The whole cake is 1,000 grams. You use the solution of one mystery to solve a second one. That is elite detective work. You're linking clues together like a master investigator. Speed round. Slide 78. Question 2. T minus 15 is 28. Add 15, T is 43. Question 4. U over 9 is 12. Multiply by 9, U is 108. Question 8. 77 equals 11R. Divide by 11, R is 7. Question 9. 6 equals Y over 14. Multiply by 14, Y is 84. See how fast you're getting? These once scary locks are now popping open in seconds. Your brain is like a high-speed math computer. Just remember the way of thinking. Always do the opposite, and always do it to both sides. No exceptions. Mission: the hidden number. Slide 79. Subtract 9 from a number and get 14. X minus 9 equals 14. Add 9. X is 23. Easy. Slide 80. Jordan is 2 kilos heavier than Haley. Jordan is 37. If Haley is J, then J plus 2 equals 37. Subtract 2. J is 35. Haley weighs 35 kilos. And slide 81, eggs in total Y divided into 8 groups with 6 eggs per group. Y over 8 equals 6. Multiply by 8, Y is 48. 48 eggs in total. That's a lot of omelets. You're translating the story of the eggs and the weight perfectly into our secret language. Mission: the savings mystery. Slide 82. Jenna used a sixth of her money to buy a $34 key ring. Let G be her money. G over 6 equals 34. Multiply by 6. Jenna had 204. She was rich. Now slide 84. Samson saved half his pocket money, which was $27. Let A be his money. A over 2 equals 27. Multiply by 2. Samson had $54. The way of thinking here, half or a sixth are just division clues in disguise. Once you spot them, you know exactly what to do. You're outsmarting the money mysteries like a financial agent. Pocket money is safe with us. Last 2 missions. Slide 83. Perimeter of Squareland is 56 mer. A square has 4 equal sides, so 4e equals 56. Divide by 4, e is 14. One side is 14 mer. And slide 85. Parco has $92, which is $48 less than Mark. If Mark is K, then K minus 48 equals 92. Add 48 back. K is 140. Mark has $140. You've tackled geometry and financial comparisons. You are truly the most versatile agents in the history of math. Every case on these slides is officially closed. Let's review our handbook. Slide 86. A number we don't know is an unknown, like X, C, Y, or M. When we add, subtract, multiply, or divide them, we get an algebraic expression. Slide 87. When we show 2 things are equal using an equals sign, it's an equation. Slide 88. The key that fits the lock is the solution. And slides 89-90 remind us of our balance scale moves. Do the same to both sides. Finally, slide 91 gives us our 5-step secret recipe. 1. Represent with a letter. 2. Write the equation. 3. Solve it. 4. Answer in words. And 5. Check. These are the rules of the masters. Now, let's take these skills to the party. Slide 92. We're at the Caring Home's annual tea gathering. Nurses and aged residents are ready for food. Slide 93 mission. There are 56 residents and 6/7 of them attend. How many are there? We multiply 56 by 6 is 7. 56 divided by 7 is 8. And 8 times 6 is 48. 48 residents are at the gala. That's a great turnout. Remember the way of thinking. When the story asks for a fraction of a total, multiplication is your secret code. Our first gala mystery is solved. Now let's find the nurses and the tables. Slide 94. Everyone is sitting around 6 tables with Y people per table. Total people? 6Y. If each table has 8 residents, how many nurses are there? Y minus 8. Now, the gift mission on slide 95. Each resident gets 3 small gifts. If there are M total gifts per table, then M divided by 8 equals 3s. Multiply by 8, M is 24. 24 gifts per table. The nurses are so well prepared. The logic remains the same. Translate the per table story into multiplication or division, and the answer pops right out. You're managing this gala like a pro. Dim sum time. Slide 96, 4 pork dumplings per basket. Uncle Wong orders several baskets. Which of these can be the total count? It must be a multiple of 4. 8? Yes. 12? Yes. 6? 14? Or 2? No. Algebra helps us spot what's possible. Now slide 97. Uncle Wong eats 5 pieces of stuffed tofu. Auntie Lee eats B pieces. Total, 5 plus B. Difference, 5 minus B. Whether it's dumplings or tofu, our secret code tracks every bite. You're even using algebra to count snacks. Now that is true dedication. Let's find the missing record card info next. Oh no! A math emergency on slide 98. Someone spilled tea on the record card. We know the total dim sum is 28. We have 0 best, 12 medium, and 10 standard. How many special baskets W did they order? Equation, W plus 12 plus 10 equals 28. Simplify it. W plus 22 equals 28. Subtract 22, W is 6. They ordered 6 baskets of special dim sum. The scale is balanced, the record is fixed, and the waitress is happy. You solved a real-life accident using your detective logic. High fives all around. One final mystery to go. The lucky draw. The final mystery! Slide 99. The lucky draw. 5 prizes total. Big prize is $545. 2 prizes are $312 each. 2 more are $240 each. Total value? We sum them up. 545 plus 2 times 312 plus 2 times 240. That's 545 plus 624 plus 480, which equals 1649. The total prize pool is over $1,600. What a way to end the gala. You've used addition, multiplication, and your secret recipe to calculate the grand total. Every case is closed, every mystery is solved, and the party is a huge success. Mission accomplished. Master agents, detectives, superstars, you have officially conquered simple equations. You've learned to speak the secret language of math, to balance the scales of the universe, and to solve real-world stories with logic and precision. I am so proud of your training. Carry these skills with you wherever you go. Remember, math isn't just about numbers. It's about solving the mysteries of life. Stay curious, keep decoding, and maybe I'll see you in the Advanced Algebra Agency someday. For now, this is Lead Detective signing off. Case officially closed. Bye for now.